Hello and welcome. Today we're going to be covering section 7.3 on the Pythagorean Theorem. Our essential question for today is how are the lengths of the sides of a right triangle related? Please pause the video as necessary to practice and write down the necessary information. Now is a good time to pause the video and fill in your essential question in your notes. Our key ideas for today. The first is that the sides of a right triangle have special names. For example, here is our 90-degree angle in the right triangle. There will always be a 90-degree angle. Across from that side is what we call the hypotenuse, and we usually refer to it as C. Hypotenuse is the side opposite the right angle. So notice this green side has no connection to that 90-degree angle. Again, feel free to pause the video as needed to fill in the blanks in your notes. There are two sides that connect to form your 90-degree angle. In this picture, they are red, and the horizontal side is blue. These we refer to as the legs. We call them A and B generally in our notation. The legs are the two sides that form the actual right angle. So the legs, there are two of them, and they form the right angle. Across from that 90-degree angle, we have the longest side of the triangle, which we call the hypotenuse. Second key idea is our Pythagorean theorem. In words, the Pythagorean theorem says, in any right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. Here's what that is saying. The sum. The sum means we are going to be adding. We are adding the squares of the lengths of the legs. Well, the legs we call A and B, and we want to add their squares. So that means we are adding A squared and B squared together. When we do that, this is equal to the square of the length of the hypotenuse. Well, the hypotenuse we call C, so the square of that length is going to be C squared. So we're adding A squared and B squared, and we get C squared. Algebraically, our Pythagorean theorem says A squared plus B squared is equal to C squared. A and B are always the legs, and C is always the hypotenuse or the longest side in your right triangle. In example 1, I want to find the length of the hypotenuse. We're going to use the relationship that we know in right triangles to help us find the length of that hypotenuse. So I know the Pythagorean theorem says that if I square one of the legs and add that to the square of the other leg, I get the square of the hypotenuse. The legs here, we are told, are 5 and 12. It doesn't matter which one's A and which one's B. So I'm going to take the first, which is 5 meters, and I square that. Then I add that with the square of 12 meters. And the final result will be the hypotenuse squared. So simplifying, I've got 25 square meters plus 144 square meters is equal to my hypotenuse squared. Adding, I have 169 square meters is equal to C squared. So if I take my hypotenuse and I square it, I find that the result is 169 square meters. So what I want to know is what number do I raise to the second power to get 169 square meters? Well, I know that I have my meters being squared, so I'm going to go ahead and fill in my units as just meters, and then this exponent says that we will be squaring them. Now I'm looking for the square root of 169, which will be 13. So what I have found is that 13 meters to the second power is going to give me that 169 square meters. So therefore, If c raised to the second power gives me 169 square meters, then just c is going to be 13 meters. So the length of the hypotenuse in this example is 13 meters. Go ahead and take a moment to pause the video and try on your own numbers 1 and 2 on your own or with your table. In example 1, I will let the 8 be A and I will let the 15 be B. So I have 8 feet squared plus 15 feet squared is equal to my hypotenuse squared, or 64 square feet plus 225 square feet is equal to c squared. When I add these together, I get 289 square feet is equal to the square of the hypotenuse. Now I'm going to get out a calculator to help me compute the square root of that 289. I do know that my units are going to be feet. Now I'm looking for two numbers that are identical and multiply to 289. I know that if I multiply 15 by 15, my result is going to either end in a 5 or a 0 because that's the rule when we multiply by 5s. So this is not going to give me what I'm looking for since my number ends in a 9. Sure enough, this ends in a 5, so this is not the number I'm looking for. But we got close, 225. That's just a little too small. So let me try 16 times 16. We get 256. 17 times 17 is sounding reasonable because I know that 7 times 7 ends in a 9, and so does my number. 17 times 17 does give us that 289 that we wanted. So the square root that we're looking for is 17. Therefore, the length of our hypotenuse, or just c, is equal to 17 feet. In example 2, I'll let A be 3/10 and B be 2/5. So I've got 3/10 inches squared plus 2/5 inches squared is equal to my hypotenuse squared. This simplifies to 9 over 100 square inches plus 4 over 25 square inches. I will find the common denominator of 100 by multiplying by 4s in that 4/25 fraction. So I've got 9 over 100 square inches plus 16 over 100 square inches is equal to c squared. Adding, I've got 25 over 100 square inches is equal to c squared. So I'm looking for just c. So I know that my units are going to be inches, and the square root of 25 over 100 is going to be 5 over 10, which does simplify down to 1/2. So the value of c is going to be just 1/2 inch. To find a missing leg, we go about this in a very similar way. The only difference is that our variable is one of the other values. So in this case, I don't know A, but I do know the other leg, so I do know the value of B, and I know the value of the hypotenuse. So when I write my Pythagorean theorem, I've got A squared. I don't know that value, but I do know the value of B, it's 2.1 centimeters, and I do know the value of C, which is 2.9 centimeters. I will use a calculator to help me evaluate these squares as I simplify. 2.1 times 2.1 gives me 4.41. So I've got A squared plus, when I square this 2.1 centimeters, I got 4.41 square centimeters. 2.9 times 2.9 is next. And I find 8.41. So this is equal to 8.41 square centimeters. I'm going to solve by subtracting my 4.41 from both sides. and our units are both square centimeters, so we are allowed to combine those like terms. And I have a squared is equal to 4 square centimeters. So that means that then just a is going to equal 2 centimeters. The square root of 4 is 2, and the square root of my square centimeters is just centimeters. So the length of that missing leg is 2 centimeters. Go ahead and take a moment to again pause the video and try numbers 3 and 4 as well as the example 3 on your own. In on your own number 3, we should have found that B is equal to a value of 30 yards. And in example 4, we see that A is equal to 4 meters. Now you should have already started example 3. You are playing capture the flag. You are 50 yards north and 20 yards east of your team's base. The other team's base is 80 yards north and 60 yards east of your base. The question is, how far are you from the other team's base? Here's a hint. Draw the situation in a coordinate plane and let the origin represent your team's base. When I sketch in a coordinate plane, I might have something that looks like this. We only have positive values, so I'm only concerned with this first quadrant. Since everything is a multiple of 10, I'll count by tens. 10, 20, 30, 40, 50, 60. 10, 20, 30, 40, 50, 60. I am going to let the origin represent my team's base. You are 50 yards north and 20 yards east of your team's base. So north means I'm going to move upwards, and east means I'm going to move to the right. If you're not familiar with the compass, we've got north, south, east, and west. So starting at my team's base, I move 50 yards north, 10, 20, 30, 40, 50, and then 20 yards east. So here is where I am. The other team's base is 80 yards north and 60 yards east of my base. So I'm going to move up north 80 yards, 10, 20, 30, 40, 50, 60, 70, and I'll extend my graph up to 80, and 60 yards east, so 10, 20, 30, 40, 50, 60. I should be about here. So this is the other base. The question is, how far are you from the other team's base? So what we want to know is, what is this distance? Well, we can make that look a lot like the hypotenuse of a right triangle. So what I'm going to do are draw the two legs that will form this right triangle. I'm going to go vertically up to 80 on the y-axis. And then I'm going to go horizontally over those yards to get to 60 on the x-axis. Remember that we were 50 yards north and 20 yards east. So we can use these numbers now to determine the length of each of these legs. From 50 up to 80, that tells me that the length of this leg is 30. From 20 over to 60 tells me that the length of this leg is 40. So now all I'm looking for is the value of the hypotenuse. So I can use my Pythagorean theorem. 30 squared plus 40 squared is equal to that hypotenuse all squared. 900 plus 1600 is equal to my hypotenuse squared. 2500 is equal to my hypotenuse squared. And the square root of that 2500 is going to be 50. So you are 50 feet from the other team's base. This concludes our lesson on the Pythagorean theorem. Thanks so much for watching, and enjoy the rest of your day.